The Millikan experiment. Robert Millikan, who lived between 1868 and 1953, devised and performed a series of experiments to prove that there exists a smallest unit of electrical charge called the elementary charge, and he gave it the symbol E, small e, of which other units are simply multiples. So E is the charge on one single electron. And let's say you had two electrons, then we can use this formula. So N stands for the number of electrons that you've either gained or lost. It's the same formula. So if you gain 2 electrons, you go 2 times E. So it would be 2 times 1.602 times 10 to the negative 19. If you gain 10 electrons or lost 10 electrons, you would go 10 times E. If it was 20, it would be 20 times E. So everything is a multiple of the smallest unit charge E. He did this experiment for about 3 decades, and this was the smallest number he could ever come up with. And you noticed everything else was a multiple of this number. So he thought, well, an electron must be this number. I've never gotten something smaller, and everything's always a multiple of it. So in his experiment, he had this positive plate, and he would suspend an electron, or sorry, an oil drop that was charged with electrons underneath this plate. So if this is positive, and let's say we had a negative charge on this, there's an attractive force. There's also the force of gravity pulling down on this. So for this to be suspended, what's happened is the electric force up must equal the force of gravity down. So the electrical force up equals the force of gravity down. We have another formula for electrical force, and that's the electric field intensity times Q is equal to, and then force of gravity is just simply mg. Well, this kind of backwards 3 is also equal to V over R. Can't forget the Q is equal to mg. Now what I want to do is just solve this for Q. So to get the Q all by itself, I'm going to multiply both sides by R and divide by V. So Q is equal to mgr divided by V. And this formula works well when you have a charged sphere just suspended. Okay, and why is it suspended? Well, the upward force due to the positive plate must be equal to the downward force due to gravity. Calculate the charge on a small sphere with an excess. So excess means we've added electrons of 5.0 times 10 to the 14 electrons. So there's two things that can happen. We can either add electrons or lose electrons. And you solve the question the exact same way. So we're looking for the charge Q. And the number of electrons that we've added is 5 times 10 to the 14. And we know that E is 1.602 times 10 to the negative 19 coulomb. That's the charge on one electron. So my formula is simply Q is equal to NE. So it's number of electrons, so 5 times 10 to the 14, times the charge on one electron, 1.602 times 10 to the negative 19. And when I put that into my calculator, I end up with negative 8.0 times 10 to the negative 5 coulombs. It's negative because I've added electrons. If I had lost electrons, my answer would have been positive. Example number 2. Two horizontal plates are 2.5 centimeters apart. A sphere of mass 1.5 times 10 negative 15 kilograms remains stationary when the potential difference between the plates is 460 volts, with the upper plate being positive. Calculate the charge on the sphere. So I know what R is. So R right off the bat is 2.5 centimeters. We know the mass. and it's being stationary. So the fact that it's being suspended stationary, we can use that new formula. The potential difference, V, is 460. And it says calculate the charge Q. Well, Q is equal to mgr divided by V. So I just plug all that in. So the mass is 1.5 times 10 to the negative 15. G is just simply 9.8 on Earth. R is, that's in centimeters. We have to change it to 0.025 meters divided by V, which is 460. When I put all of that into my calculator, I end up with 8.0 times 10 to the negative 19 coulombs. So part B says, how many excess or deficit electrons does the sphere have? So I'm going to use the formula. So I'm looking for N. I'm looking for N. And I'm going to use the formula Q is equal to NE. Because I know what Q is. I just solved for that. E is a constant. That's 1.602 times 10 to the negative 19. All I have to do is rearrange for N. So to get N by itself, I bring the E over here by dividing it. So N is equal to Q over E. Put in my Q. Divided by my E. And when I put that into my calculator, I get 5.